Hey guys, this will be video 7 for the how to restore a vintage Gibson SG, and this is still a 1969. A couple of things I'm going to cover in this video is we're going to finish the neck fitment. Not completely finished, but I'm going to show you everything that I go through in order to get this thing ready to finish your machine work. And after you get it fitted, and you're comfortable with it, then this the body's ready to put over somewhere where it's really safe, because you've got a lot of work to do when you're preparing to move into your tapering and doing the headstock ears and an enormous amount of work. So we're only about 20% through the job right now. Give or take. I don't even know why I threw that number out there, but it might appear as though, oh, we're getting ready to put the neck in. We're like 50% through. Now, there's still a ton of work. Sorry about that. There's still a ton of work to do. In addition to the neck fitment, and even down to the point of like sliding paper in here and testing fitment and stuff like that, I'm actually going to cover that in the first half, but I'm actually going to go into a little bit of a general conversation about structural integrity and the mistakes that were made with the design of this guitar that were such a shame that and a lot of people have said this. Even George Gruen himself, I heard him make the statement like, I don't understand why they made this body so thin. It could have been just a little bit thicker, like the Explorers that they were building in the 50s, and would have still been a super light guitar and would have been such a much better design. It's a fine design right now, but it could have been substantially better. And you guys heard what happened when all I put in was like a 1/8 inch thick quarter sawn Honduran mahogany fillet in the bottom. Well, we got some rattlies back here, but it just, not only did it improve the structural integrity 100-fold, it really added to the tone. So, and that prompted me to think about this chintzy ass top up here. Why they went so thin? That makes no sense. So you might hear me get a little bit irritated with some of these things, but I'm hoping that I point out the way I build my Explorer replicas. I don't do that thin top. I make my Explorer replica tops in that location. They're 7/16 of an inch thick, okay? Whereas this one is 3/16 of an inch thick. That's too thin, way too thin to be that large of an area routed out, okay? And we all know they were prone to a lot of major, actually catastrophic breaks right there. And if the plug was left in it and it got bumped or kicked or something like that, it would crack the top. So anyway, I spent a little bit too much time talking about that. But let's talk about fitting a neck first, and then or finishing the fitment. I'm going to keep this very general. Oh, I've got that piece of tape on there. This is really funny. In video 6B, when I was doing the epoxy work right here, I thought I had touched the side of the body with my thumb that had a little bit of epoxy on it, but it wasn't. There's a piece of scotch, and I kept thinking, oh, what the heck is that? And the video, my camera storage was maxed out, and the video cut off right before I could say, oh, it wasn't me. It's a piece of scotch tape that's on the body. Possibly where when they had it for sale, they might have had some scotch tape on there with a price tag on it. So, because I kept looking at it going, what the hell is that? And it kept remaining kind of sticky because I hit it with some mineral spirits. But so Eric, I'm redeeming myself. I did not get epoxy on your guitar. So anyway, it's all good. So let's talk about fitting a neck to a guitar. What have I done since the last video? I did do just a little bit more shape work on this side right here. Where's my saw? I was going to show you guys a trick. Rather than getting out files or rasps, or especially little sanding blocks, it's amazing how quickly these little things can get you in trouble. If you knew that you needed to remove a little bit of material just up in this one corner, like where we had relieved the side going into the tendons, there's usually always a little bit of extra mass left in there. So you have a tendency to want to come in here and start doing this right here, but you run the risk of bumping into this outside line. And as I said, this is the finished guitar. And we've got to really pay particular attention to this, because what's really frustrating, there's still a lot of work to be done with this neck, and we've got to protect. I say I've got to protect this corner here, uh, you know, as if it is important, and it's insanely important. So, but where I was going is, what you can do is you could take like a little bit of a pencil marking, just scratch it up a little, put some pencil marks on it, and then take a saw, and you can even do a hacksaw blade, and you can just kind of, where I'm going is, you can look down and you can see the teeth, excuse me, and you can see the light shining behind the little teeth, and you can actually watch as the dust is coming off this. You can scrape across it and just keep the blade, flat on there, and just scrape across it gently. And then you're not laying it over, risking that. So you're just kind of, if anything, you could put it up in that corner and kind of pull out, but you're just cleaning off whatever little hump might be there, and maybe kissing it right there, kissing it right there, kissing it right there, kind of making certain there's nothing in that corner. Okay, so use that. A hacksaw blade works really well too, because they're real stiff, and you can just get in there and really do some nice little trim work, because you can see how I furred that up a little bit. So you're getting really close to the finished job when you're using little tools like that, and it's just beginning to clock. And you might think, oh wow, that's awesome, that's perfect. Well, it's almost perfect, but where it's clocking in the back. It's making contact in the back of the body, but it's also making contact on both of these sides. But there was just a little bit of a gap on the bottom there. So I'm going to go ahead and in real time just process through some of this, and show you how I fit a neck. Now, how I would be doing this is not here on this loose table. I would use my miter saw stand that I built over there specifically for doing this type work, and I would put a cloth on the table, and then I would put this block up in here, and then I have a little 2-foot level that I lay across there, and I do a quick grip clamp out here and a quick grip clamp out here, just enough to keep the body from moving, and it's suspended off the table. Then I've got a light that I position over there, and then I'm able to, the body's really low, so I'm able to lean forward and look straight down and maybe shine a light under it to see if I see daylight, or I'm able to stoop down and take my, because we are down to the erasure shield point now, and as the body's holding itself in place, now I'm basically up here just making certain that I'm bedding in this, and I'm coming across wherever there's this one's so flush right here, I can't hardly find a space to get to it. But you're just taking the erasure shield and you're looking for voids. You're searching for voids, and I think right now there's still just a very minuscule void right here. But I did, before I turn on see, there's just a bit of a minuscule void right there, and you might think, oh crap, okay, then we need to start sanding over here to get that under control. Well, as I had mentioned, this is when you need to have your paper out and ask yourself, are you clocking out here, or are you clocking back there? And the way you test that, put your paper in the bottom right hand corner, press it into place, and you see that? See it's binding? Okay, so we know it's binding a little bit in that back corner. Okay, it's not too bad right there. But what that tells us is we need to take just a little bit of material off of this heel. Now, if I was getting ready to glue this in with Titebond, when I say a little bit of material off this heel, you saw how the paper was coming out fairly well on the side. I would probably only come in here and just take a little bit of material off this side right here, because we're going to be getting an enormous amount of structural integrity out of the end grain here, gluing to the end grain of that board, that cross member that I've already covered in the past videos. That cross member being there is a lifesaver for this body because it's so super thin right here. And even just that right there in that distance, that's not that bad. But once you start machining down for those feet, and when you recklessly machine out all of that absurd area for these little bitty feet that only needed just a very small amount, that's completely unnecessary. But it's too late now; it's there. But let's make certain that when we fit this, that we don't just go over to our miter saw and chop off a quarter of an inch and leave a gap back there just because we're trying to have somewhere for the glue to squeeze out. And when I made that statement in the last video, one of the last videos, I was like, well, you want to have a little bit of space back there for squeeze out. Yes, you do, especially if you're gluing the neck in with epoxy, because what's going to happen is that epoxy that you're working out of the pocket, you're pushing to the back, and it's coming up. Then yes, you do want that to squeeze out, but you want it to remain in there and act as a join between the butt end of the tenon and that back wall right there. That epoxy will be just as strong and even tone transferring. That's what I love about the epoxy, because it'll dry more brittle and it will actually end up being an excellent transfer of the tone. If you glue this in with Titebond, it's still a really good guitar, still a really good joint, and it's fine. But back here in the back, if this didn't make a perfect, real nice kiss contact back there, then you're gonna, wherever that Titebond glues, wherever there's a void, well, it's a rubber gasket. And if you put a rubber gasket between anything, you kill the sound transmission or the vibration. So all the more reason to use the epoxy. And I'm not bringing up something here that I haven't done numerous times on past guitars, and I've already covered this in the past videos. But for you Gibson cork sniffers out there that think that you ought to build this guitar so that it's easy to get the neck out, well, airplanes aren't designed to be crashed, and guitars aren't designed to be dropped. So, but it happens. We know it happens. My theory is build this guitar to, as I said in one of the early videos, I want this neck to lend additional strength to the body, just as I want the body to lend additional strength to the neck. If this guitar falls over, we know that it's going to be breaking up here in the middle of the neck or up at the headstock. And if you have a really superior glue joint down here, even if this is Titebond, I could glue this joint in as tight as it is with Titebond, and it would be stronger than most joints out there. But if it falls, I don't want it to come apart down here, nor do I want it cracking into the body or ripping out, the back area of the mortise here. I want all of this to stay intact. And then I'll determine how I'm going to repair the neck up here, or at that point, if the fretboard is still salvageable, then remove the fretboard and simply come in here and take a really nice jigsaw or bandsaw with a metal blade on it, because you'll be cutting into your truss rod. You'll be cutting the truss rod in half, and then I would want to come in and just completely saw the neck off, and then chisel out the remnant of the truss rod, and then set up my routing jig, and then reroute every bit of this neck out if I'm going to do a full neck replacement. So, not to be dramatic there, but that's how, if you're running a production shop where you're trying to make money, you don't have time to sit here and be ginger with these little tools and ease this neck out because you're trying to protect the tenon when it doesn't even have a functional headstock anymore. But with a very strong join down here, any work that's going on up here, it will allow the guitar owner, the player, collector, whatever they are, to make the determination of, no, hell no, man, I'm a touring guitarist. I don't care what it looks like. I want it repaired properly, and I need a new headstock. And then you're up here making the determination of how you're doing the repair, or either you're letting the guy know or the girl know that, hey, this ain't going to be a 5-day job, So, but I've seen too many pictures of guys that have sent me images of like, oh, I've got a 1976 pick your poison, or I got a 1982, or I got a da 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 da, and they'll send me these pictures of where there's this horrific fracture here, and all that happened to the guitar was it just fell over and took a blow right here, and it might have split the neck a little bit up here, headstock up here, or sometimes it was completely broken off. But if it had been a more superior join, then it would have sustained no damage down here. Sorry to rant and rave about that, but it's one of those things that I understand what some of these companies are thinking, but quite frankly, if you want to go that route, well then go the Leo Fender route, because he was the only one that really had a design that made sense, where you don't have all this tip pitched headstock, and it's a bolt-on neck. If Junior did fall down the stairs with his guitar, then it's pretty easy to just buzz those screws out and throw the new neck up in there. It was brilliant. So nonetheless, that this company did not take that route. But if you're going to do the mortise, if you're going to do the actual mortise and tenon type configuration, well then you need to be doing it per jazz guitar standards, and you need to be doing fitment like that right there. But what does that cost? It costs money. It costs an enormous amount of time and craftsmanship in order to do it right, man. Okay, so you see what I'm saying here? When you do good work, it starts showing up, and you see how nice of a fitment and I haven't even fit this yet. This was just from the initial machine work. I'll give them the benefit of the doubt, the credit. I'll give them the full credit here. This plane is perfect. So fortunately, the plane they initially machined is absolutely perfect. And if there was a poor fitment, it's not this company, it's me. It's my inability to build a neck. But since we do have the ability to build a good neck, and with these little side fillers that we glued in, and strengthen up that weird design they had, the deep V, this now permits you to come in and not worry too much about, well, maybe I need to raise that neck up. A guitar pick thickness, as I mentioned in one of the videos. You're not going to put that in there as a shim. You're going to be adding a maple shim, but that would be a use by which you could raise the whole platform of the neck up in order to get I feel like I'm holding the violin here, in order to reach a target, maybe if you were a little bit too low. But the good thing about this one, it's perfect. Just right here. Once this fretboard goes in here, make sure I'm bedding. And once I come across the fret and then the string height, which is above the fret, just about a 32nd of an inch, I'm landing perfectly at my 19 millimeter at the D, E, A, D, and G, the D and the G. At the bottom of the string, I'm hitting about, actually it's going to be about 18 millimeter. Right now it's roughly 19 millimeter, but that is an unslotted saddle. Okay, that's just at the top. So there you have it. Quality work. What's going to happen to this guitar? It's probably going to be one of the best sounding SGs that's ever been played. And I'm not being arrogant. I'm just saying, once you join these locations like this with the right product, type 1 would be fine, as long as you trim that off a little bit so you get a good seat around the other sides. That's going to sound incredible. All right, I spent a little bit too much time talking about that, but I got to drive it home because I'm getting a lot of comments from guys who act like they know what they're talking about, and I'm trying to be real nice and refrain from being an asshole, which I can be, but I don't want to be, because I know there's a lot of guys out there that especially have just come on board. And I think 99% of you guys are really sincere, and I appreciate that. I appreciate you subscribing, and I appreciate the feedback, and I appreciate the communication. But for you cork sniffers out there that think you know what you're talking about, it's obvious that you don't when you start making certain statements, because this is so critical to get these joins correct. Okay, so per our original, let me check the time. 19 minutes of ranting and raving. Okay, so it sounds like we're clocking, but in all actuality, I think what's going on. Yeah, see that? See, that's not making contact. So what's got to happen with this job right here, I've got to go over to my miter saw and shave off a very minimal amount. And let me pause. I'll go ahead and do that. Let's see if we can get this under control. Excuse me, but I don't want to spend 25 minutes talking about this right here. So let me pause. Okay, before I made that cut, I came across this with a pencil and made a little bit of a pencil mark because I literally just shaved off the surface. And when you do this, I forgot to mention, I did square up the mortise, but what you want to do is you do want to ease the edge on your tenon a little bit. And what that will do, that will guarantee you that if there's just the slightest little bit of a bump in here in one of these corners, then it'll float around. You don't want to radius it, but and then back here, especially on this bottom, this is kind of an area that can be problematic. You want to ease that edge a little bit, definitely round off that corner. But, you know, again, not too much. That will just guarantee that you won't get a faulty reading by bumping into a little piece of material that might be sticking out. Because see these dowels in here, I had to come in here and I thought I was nice and square, but that dowel where it had broken off, there was a little bit of the dowel still left, and I had to shave that off. And what that would do is give you a false reading. So I'm nice and perfectly true, and then just come out, because see, I epoxy that in, so I got to make certain that I don't have any epoxy bubbling up as well. So I think we're really close to a finished guitar, and I'll spend just a few more minutes with this. Okay, so I'm able to get my paper in there, which is fine. And this is a thicker cardboard top, so that'll give you an idea of just how close I am. I could just, no, I felt the neck jump out because when I tried to put that in there. Yeah, it will. Yeah, we'll go down in that area a little bit right there, but not too bad. So we're in good shape. But what I did do is I realized that okay, there's still fitment that is required. I don't think it's going to be possible for you to do this machine work and this fit up in here perfectly. You're still going to have a little bit of a gap somewhere, but you have to start determining, well, what is causing that? Is it the pitch, or is it over here, or maybe it's the way I machined this by hand. I might have gotten this cut just a micro measurement further in, so this is making contact over here. Well, that's not a big deal, because all you want to do then, and this will give me the opportunity to show you how to ease your way to the finish line. Let's say you had a gap over here, but it was nice and tight over here, and it was pretty darn good on the bottom, but it looked like it needed to go in a little bit. Well, one way to do this is have some sandpaper, like a 400 grit. This would be the back surface of the sandpaper. This is the grit side. So keep in mind, you got your body kind of clamped down. It's not moving around the way it is on us right here. And then you just don't push it in real tight, but just push it in gingerly, and then draw your sandpaper through it just once. Blow it off. Check the fitment, and see if that was all it needed to bring that in. And then if it's still got a little bit of a gap over there, drop the paper back down in there. I didn't want to do this with real sandpaper because I have not fit this neck yet, and I don't want to create a problem that doesn't even exist, because this is one of the best initial fitments I've ever had. And then, see, I'm a little bit too tight right there, so loosen the guns a little bit and then slide through. And then what that will do, Also, if there's some funky contour going on back here, like a historical guitar that's really old and this is really rough, then you can actually, the paper will follow, the sandpaper will follow the wonky contour that might be going on either of these three sides, and it will do a wonky fitment that will actually be visually beautiful. And you didn't come in here and try to clean up something that you run the risk of creating tear out on this side. And speaking of that tear out, I'm at a point to where I almost sealed this with a nitrocellulose lacquer just to give that wood some strength since it's so old and dry, because you have to be real careful. Just the slightest little bit of sanding across here could cause fleek out on that original joint, and we don't want that type stuff, because you can see where the body had experienced a lot of splitting, but not anymore. Okay, so it's all good now. Okay, so I'm not going to talk about neck fitment anymore at all, because I'll shoot straight with you. I'm kind of tired of talking about it, because all the work that I've done over the last 3 days and tried to explain, man, it could have been done in like 3 or 4 hours. But doing the videos, you got to really slow down and take the time to think about each different stage. But at this point, well, everything you were trying to achieve was based on the center line of this bridge, the center line of the guitar. Well, not necessarily the center line of the guitar. Wherever that bridge is from your manufacturer, then let that be your center line target. And fortunately, I'm excellent. I'm hitting it perfect, spot on. You might put a piece of tape up here if you haven't done your truss rod yet, and find the center of your neck, because it's very important that you keep that truss rod perfectly centered with the actual fingerboard surface. You wouldn't want to come in here, I'm going to exaggerate, but you wouldn't want to come in here and offset everything and just to make it work, down a straight line, because now your truss rod would be pulling on an angle and you would end up with a twist. So the truss rod has got to be nice and true, nice and straight down the center line. Read between the lines. I think you guys know what I'm talking about. You don't want that truss rod doing anything too crazy. If that's the case, then you might want to consider cleaning up the machine work. So at this point, one thing you had to verify, can you catch your fingernail right here? Can you catch your fingernail right here? And obviously on the bottom. So once you know you're good, you're actually ready to, man, I'm so tired of talking about this fitment, but it's a necessary evil. But now you're ready to take your mechanical pencil that is missing in action. I guess I'll just have to use this one. But now you're ready to take your mechanical pencil, because I will say this heel is really funky, but you're ready to actually come in here and actually trace around that, and then make the determination of how to relieve that material. The last thing you would be doing is obviously fitting the neck to the body and then trying to do all this shape work with already in the body. So with that said, the body is basically ready to push over to the side and talk about how to start laying out your center lines. And now that we've got our pencil marks that we identified from the heel that is original, now we're going to be making a determination of installing the fretboard, not installing the fretboard yet, but laying out the neck in order to be tapered. And every bit of this is going to depend on the nut width you go with. Unfortunately, the width up here at this location is about 1/16 of an inch more narrow than I've ever built. And it's actually about 3/32 of an inch more narrow right here than I usually build. So I'm going to be cutting it really close. Well, I say that. I mean, I shouldn't have said that, because I don't need to put any fear in the mind of the client. I've already laid out the string path, PATH, from the center of both E saddles to the nut location that we'll be going with. And this width right here is perfectly fine. But I won't be able to come in here and bevel these frets on a 60-degree slope. I never do that anyway. I'll still be able to bevel the frets, but fortunately, we're going to have binding on this job. So it's going to be a fairly complex fret install where the fret will actually hang over the binding. And most people think, oh, God, then that means it's going to be a palm catcher. It's not, because the neck is going to roll. But the thing about this is once I go over to this side, especially up in this location right here, the fret angle that I'll be cutting will probably be something about like that right there. And then once I lay out the string path, then I'll make the determination on the final bevel on the treble side. Every bit of that final bevel will be done by hand after I've played it for a few days, because I'll have them in there fairly steep, and then I'll make the determination of just how much I can bevel. And I might realize, oh man, I was just overreacting about something that wasn't even an issue anyway. So, in other words, I'm not there yet, but just know that there are ways that you can treat this and still have a really beautiful bevel, at about probably about 80 degrees, something like that. And it feels great. As long as it's dressed properly, you're not going to feel any of that at all. So, anyway, read between the lines. We're not there yet, and it's one of those things. Don't jump the gun, and once you do all this fret work, don't start beveling these, because you might regret it and wish you had have left a very small amount there left. Okay. All right. So taper would be the next thing, because what's about to happen with this neck? Typically, by now I have already installed the truss rod and this fillet, and it's epoxied in, and all this is finished, like this guitar over here. So I would now be ready to actually define the taper, and according to center lines and everything. And because of this weird little narrow area right here, if there's a little bit of cowboy engineering going on where I had to shift something a 64th of an inch, well, now's the time to make note of it and maybe take that 64th of an inch off more on this side than this side, because this lower that I'm holding right now is, I think it's about, oh no, it's pretty close. It's about a 16th of an inch. It's about a 32nd of an inch wider on both sides. But when I fit this, yeah, no, it's hanging over about a 32nd there, and it's hanging over about, would it be 3/64ths, like a third of a millimeter or 2/3 of a millimeter, something like that. So in other words, I got room to play. And then what's going to happen down here is just it's basically going to be getting a heel basically identical to that right there. And you can see that taper that's on there. What that is that's a past, probably a Les Paul replica that I built, where that was the excess material that was on the bottom that got shaved off with one of my pull saws, because that shows you the little bit of taper that was already, the rounding that was taking place right there. Okay, in other words, right there. This body being so thin, everything about this is going to be extremely low profile, but we still want to see that really beautiful defined Gibson heel. That's where I'm going with this, which is also a Gretsch heel. They're basically identical, like a vintage Gretsch. Okay, now the modern Gibson is a little bit more like this, right? Well, that is a modern Gibson. That's a 1980, which I'm getting ready to restore this 71 Les Paul Gold Top as well, which is an authentic Les Paul. It's this identical profile right here, but it's just a little bit deeper. See how this one's considerably deep? I'm going to say considerably deeper. It's about an 1/8 of an inch deeper, but after it's all shaped and sanded, it's going to feel like a 58 Explorer. I mean, it's going to feel incredible. So it's not going to be any hanging up, because we're already we're at the 19th fret. See, this being the Les Paul, everybody knows that's the 16th fret location, and it lends you the inability to access nearly as well as you do with the SG. Okay, check the time. 35 minutes. God, it felt like it was 50 minutes. I was kind of scared to look at the timer. Okay, so we know where the neck is going, and it's on center line. All that is good. So now we just know that when we're getting ready to do our taper is going to be based on. Let me push that all the way over to the side. See, that'll show you the gap right there. But this little fretboard that I designed, this is actually intentionally made smaller in order to receive binding on either side. So once it's not for this guitar, but once it receives whatever guitar it goes on, it will be receiving binding on both sides, and then that will make a. Well, actually, this one's designed to receive multi-layer binding, where you'll have a black, white, or you'll have like black, white, black, and then thin binding, black, white, black, and then thin binding out there. This is like a jazz. This would be for like a jazz guitar. And as you guys know, it would come out flush on the side and be really pretty, and then be shaped with the top. It's kind of wonky, so we can stop talking about that. But once you know the nut width, then you're just engineering everything down to that. And then if you've got a little fretboard like this, then you're just drawing a pencil line, a trapezoidal path pencil line, PATH, and then you're making the determination of how do you want to go about creating that taper. And probably the easiest way to create that taper is to have a jig like this, and then you double side tape that down really strong, and then you run this on a tabletop router where you have a bearing on the bottom and the bit projects up, and then you just very gingerly ease off that taper, even if you have to create some sort of stop point down here that forces your bearing to stop at a certain location. But by doing it on a router table, you're able to actually watch exactly where the router bit is cutting on the neck. So that's a real nice way to do it. And then back here at this location back here, it's based on wherever your pencil mark was here and wherever your pencil mark was here, but it's definitely based on that width. The only thing I'm going to mention, mine's going to be a little bit wider because I want room to come in here and do some feather work, and I call it trickery. I want to do a little bit of trickery because by the time you get up to this fretboard, I don't want this to feel like a child's guitar. I want this to feel like a normal guitar that's right at its threshold of its minimum width. And in other words, there might be just a little bit of flare work going on that's not detectable visibly. And I'm not there yet, but I'll be doing that flare work with the binding, basically. And it might even be that if you were to exaggerate it, there might be some sort of flare work going on that might even twist in order to make it come together. But when you're looking at it from the top, you see a beautiful, perfectly accurate trapezoidal path on your fretboard. Again, this is extremely narrow, and to the point where I was like, oh God, what am I going to do with that? But it'll be fine, Eric, so no reason to fret. Okay, so I talked about the trapezoidal path just enough to let you know, we all know it's got to take place, but I'm not going to start talking about how I do that because that's another video for another series. Time. Still 39 minutes. Okay, what can we talk about here before? Because I want to start talking about structural a little bit, as I mentioned on the front of the video. Because I'll shoot straight with it. I'm kind of burnt out talking about that joint right there, and I'm sure you guys are probably kind of tired of hearing about it as well. So let's change gears and let's talk about some things that could have been differently with this design. Okay, from the front, they look like they're the same. Let me get this off so it doesn't fall. In case I do some tap tone, take that down. Okay, we know that they had the tall potentiometer in the 50s because they were putting them in the Les Paul, and if they had this tall potentiometer, my question is, why did you go with this wicked thin dimension? And let's see what that dimension is. Because I'm looking at this from a standpoint, if I'm the owner of this company, I want to minimize damage and warranty issues. That is, to me, that's more important. Well, that is minimizing damage and warranty costs is just as important as efficiency in every aspects of the business. Okay, so what is the thickness of that top? I know it's 3/16 of an inch, but let me give you the metric as well. Yeah, it is 3/16 of an inch, which that's ridiculous. Um, it is that 5 millimeter? Yeah, it wasn't even 5 millimeter. That is so thin. It wouldn't be that big of a deal if it was like the Explorer design, where it's just a single line. But that mass of an area, uh, knowing that they had these in house, uh, going straight to the finish line, this could be 7/16 of an inch thick. Why? Because that's exactly what what I do in my Explorer replica builds. I don't do these a quarter of an inch or 3/16 of an inch thick. They are 7/16 of an inch thick. Now let's see what that contributes to the top thickness. That's awesome. It leaves a 7/16 of an inch top thickness up here. That didn't get paper thin. This is a black limba. This is extremely dark wood, very dark wood. But nonetheless, you don't have to worry about cracking that. There's no way I would do that on that guitar. I could just about guarantee it would crack. Okay, not being dramatic, but no more dramatic than what it feels like if you drop your guitar and it bursts the top out of it. Because in addition to these potentiometers, they were also, as we know, putting the jack here, plus they had the three-way right there. So when you're looking at from an engineering standpoint, why in the hell did they do that? That literally makes no sense to me at all, because they should have known, oh man, just the first time Junior falls down the stairs, it's game over for his guitar. And you can see how, well, I will say this. The only credit I will give them is they were probably fearful that once they start coming across here and trying to do their solder work, then yes, it would have been an issue. But you could have made the guitar maybe a little bit thicker, or you could have shown off your ability to do your solder work. I'll try to show that because that's really impressive. From a visual standpoint, to me, that would be worthy of putting a clear acrylic pickguard, control cavity cover on there. If you were, having your braided wiring put on the back here, and then you're just doing a real sweet, gentle solder joint on each side, and then you're coming in. If that's the volume, is that the volume? No, I think that's the tone. I'm looking at it upside down, but let's say you were coming in like that. You could come in from the sides where I'm going with this. I get the point though, because I take that back. You would have to come in the middle right here, so that might be a bit of an issue right there. But nonetheless, it was pretty close. Because where I'm going with this, you could actually go up a little bit taller, but I'm at the bare minimums right now. I just really think if they had done a little bit more engineering, they would have been able to use the taller potentiometer. But that's the 3/8 inch, and that's what will be going back in it if I do the harness. We're considering. I'm sorry, Eric's. I think he's got a harness, and he's considering me going ahead and wiring it up for him. But we're not there yet. We need to talk about that a little bit more. But I just feel like that would have added some additional weight and strength. Not doing this runaway route work right here would have added a little additional strength right there. And I don't know how many years they did the deep V. This is much more similar to like the 50s, the early 60s design. And I imagine later on they went back to just a traditional route and probably learned their lesson about tapering that too much as well. Okay. And then I'm sure all this is done with a CNC now, so this is probably just minimalist routing up here. So, oh, and I know what I was going to say. Even if you had the potentiometers up there fairly high, you still had room to drill that access right there. I'm sorry, what I'm getting at is the wiring channel did not come out really close to the front of the body. It came out much closer to the back because it's on that pitch right there. So that's obvious that they had some sort of jig that once this body was set in this jig, they were able to take probably a handheld drill. There's probably a person there with a handheld drill that kept a 3/8 inch bit in it, and they set it down, and there was a little cradle right here that probably had a little horseshoe cut in it, and it guaranteed that that person pulling the trigger on that drill went in on a perfect, and it probably even had a pilot on the front, and then that guaranteed that they stopped at a certain depth, and it was they didn't run the risk of, you know, obviously coming out of the body. Okay, what else? Can't really think of anything else I want to talk about, cover. I just feel like they could have gone with the longer potentiometers and had a thicker top, and that would have saved the life of that guitar. And I don't know what they're doing today, but it wouldn't surprise me if they're still doing like a 3/8 inch potentiometer in there, and probably the same thing on that guitar. Doesn't matter nearly as much as I said because it's just a single line slot, but it would have worked. Okay, all right. Let me check the time and consider whether we might get lucky and get out in 45 minutes. Let me pause and get the table under control and think about what I might want to talk about, because I don't want to talk about this neck anymore as far as fitment goes, and I know you guys probably don't want to hear about it anymore, and then we'll go from there. So let me pause, and I'll be right back. Okay, let's finish out the video from a theoretical standpoint, and I want to make certain that I kind of verify this stuff before I create a situation that might not work. In other words, this might not work, but let's see if we can make it work. By having the adjustable nut on the bottom and the actual locking washer, we got to have that to keep it from coming loose. This one, the way this is designed, the thickness here, you're not able to put an adjustment nut on the bottom. You're only able to bottom out the actual locking washer, throw it in the body, and then put the actual face washer down, and then the face nut. Game over. It's awesome. They don't even have to think. I get it. That makes sense. So if they had this in-house, they were making this easy so that it just went together and no one had to sit there and adjust the height of this backing nut. Same principle applies to this guitar over here. When I designed the tops at 7/16 of an inch, it allows me to take this tall potentiometer, take this adjustment nut all the way to the bottom. It is on there, and then the locking washer goes all the way down to the top of that. It slides in the back of that. Then once it comes through the body, the face washer and the face nut torques up the actual traditional knob is just ever so slightly hovering off the top. It's an easy operation. So it should still apply to this guitar by leaving this top 7/16 of an inch thick. But let's look at something that might be related to the wiring. I'm sorry. Let me take that up as high as I can, and I'm really trying to make it as difficult for us as possible. See, that's kind of your target. You want to see about 3/16 of an inch of the thread sticking out. And see, since that's a volume location, okay, I'm going to be fair to myself. Yeah, I'm a little bit conservative there. I've got this. Sorry, I want to make sure, because we're splitting hairs here. I'm pushing that potentiometer as close to the back as possible. Should be good. God almighty. Sorry about that. That one really is kind of irrelevant because we know there's plenty of clearance on the back. Okay, so let's cover this first, and then we're going to talk about the possibility of putting a short switchcraft toggle switch rather than the L type, because this is an absolute cluster. You know what? Up in here, there's so much crap going on that I guess this turns in like this, and it might be easy because all the little runs are really short. But what I hate about this, it forces the SG player, or it forces the Gibson player that might like the idea of changing the direction of the toggle switch to having to go up and down only. In case the camera cuts me off, just know that if you go with the short toggle, if it will even fit in the body, and unfortunately I don't have one, you can then rotate that toggle so that you can toggle in any direction you want. You could toggle straight with the guitar, you could toggle on any sort of angle, and it's a far more comfortable playing guitar. I've learned that when I was building all the Flying V replicas, the location of that toggle, it worked out really great if it was just in line, because I could reach down with my pinky and pull it forward or pull it back to shift from the neck to the bridge. So let's see if you can do the wiring here and get away with it. And I just want to cover that three-way thing because that's one of the main things that I always hated about the SG. Literally hated that. I hated that toggle going up and down. It's really felt uncomfortable. Okay, so if this is the volume potentiometer, this terminal coming in right here is going to be coming from the actual, from the pickup, okay? It can be soldered on the side. If it's soldered on the top, and I'll give them this, it's just barely, it would just barely give you room to get the pickguard down. So you really don't have the option of soldering any of the braid wire on the top. So you would be soldering that pickup terminal on the side, wrapping around. It would be really cool. It would be hidden and everything. And it would leave all the identification numbers visible so that 50, 60, 70 years later, you could date the potentiometers with ease. Okay, this terminal here, this lug always gets folded over and grounded. Okay, this being the volume. But in the middle, that is the wiring coming from the pickup selector. It comes in here in the middle. It would not have to come across the top, but because I will say this, on the Les Paul replicas that I build, I come across the top like that, and then I solder back here just because there's plenty of depth. But you don't have to ground onto the potentiometer because you've already got a real fine ground wire connecting all the potentiometers and even to the ground wire that's coming out of the body. So all you would have to do is come out of here with your braided wire and connect out here and then ground somewhere in that perimeter wiring. And that would leave the potentiometers completely exposed. So neither here nor there. I'm not saying let's go back in time and change everything, but if you're getting ready to build an SG replica, plan on that. Machine your body 7/16 of an inch deep, and go with the long shaft potentiometer, and you'll still get enough. You'll be able to get the potentiometer low enough that your actual, wherever the little knob is, it disappeared. The little knob will float perfectly. Check time. 54 minutes. Yeah, there it is. Okay, we don't want it on the body, but we sure as hell don't want it up here because we're goofy and we're trying to put a potentiometer that was too tall. So let's talk about. Let me just show you how this works. A lot of guys don't know this, but if you're doing a through body design with your Switchcraft three-way, you can use what's called the deep well. I use this on practically everything I build, even on the, well, let me stop talking about that. Okay, so, and that's exactly the way this one is. But see, right now, this one is only directional, either that direction or straight up and down. To me, that's too straight up and down. It would be awesome if it was at least right there. I could deal with that. That wouldn't be that bad. But there's not room in the control cavity for that. But if you go with the short, straight Switchcraft, I am not left-handed. See, this is going to be obviously too long. You know, oh, it's sticking out of the body. But, you know, it's going to be too long. Let me see if I can turn that around so it's not body. But the cool thing about this, now you're able to rotate and put your SG Switchcraft three-way wherever you want. And Eric, I'm not certain, like if I were to build your wiring harness, I could engineer this and give you an absolute definitive yes that the short three-way would work, would clear, would be perfect. And that would allow me to do more directional control, but I can't do it with the L type, which I hate that thing. But it might. This body's so thin, even the short three-way might not work. But wouldn't it be nice if you had the ability to rotate that in any direction you want? And even if you wanted it straight up and down, maybe some players want it straight up and down where you could just throw it like that. See, you don't have that directional control with the L type because you're crashing into potentiometers. You run the risk of grounding out or arcing and stuff like that. Okay, so I think I drove my point home. I got to rant a little bit about design flaws and problems that create warranty issues and stuff like that. But I just really think when I look back on some of these past builders, I got to give Leo Fender a huge applause because, man, he came right out of the gate with his design team and the build team and built an insanely efficient guitar that was so problem free. And I love a set neck guitar. Don't get me wrong. I don't own a Fender product. I've built a lot of Tellys and I've played a lot of them, but as soon as I'm through with the Telly fever, I sell them as quick as I can. And the Strat, never cared for the Strat, but from a design standpoint, you can put the thing in a case that thick and ship it all over the world. Whereas if you're building an Explorer or like an authentic Explorer or a Flying V with a deep set pitched headstock, man, that thing's in a case that thick, that wide, 48 inches long, and you could have put two Strats or two Telecasters in that box. So when you're building these set neck guitars, they need to be more expensive, obviously, because there's a lot more engineering going on here. An enormous amount more engineering to build a set neck guitar with a pitched headstock and all that jazz. And I say jazz, those are like jazz guitar standards when you're doing that type stuff. But do just a little bit more, and this guitar would have been even better than what it is right now. Okay, so read between the lines. I still love the SG. It's an awesome guitar, but I hope that they have worked through a lot of those things and remedied them. 59 minutes, and I'm surprised the camera hasn't cut me off. So if it just cuts me off, it just cuts me off. I appreciate you guys dropping in and suffering through a long-winded video, but I think we covered a lot of ground. And I'm looking at the table. I don't really see anything else to talk about because I see some tuners over here I want to talk about. but I don't think we'll have time to talk about that. So we'll cover that in the next video. And the next video for this guitar, this neck is going to pretty much be shaped and ready to go in because I'm getting ready to do the Les Paul build, and I'll cover some stuff in that that I'm not going to cover in this video series. Okay, so appreciate you guys dropping by. And if you got any questions or comments, let me know. If they're dirty comments, I'll just leave them up and let everybody throw bamboo skewers at you guys. So appreciate you guys dropping in. See you next time.